All right, we're going to keep practicing identifying the difference between linear functions and exponential, and we have to write the equations for both of them, okay? As mentioned before, I told you that numbers, okay, how do you identify if it's going to be linear or exponential? Linear or exponential? It's very exponential. It's going to be really easy because linear numbers, again, I told you you're either adding or subtracting whole numbers. Exponential, since we are multiplying, and don't forget that we have that 1 plus r or 1 minus r. Don't forget about that. Remember that those numbers, the r's, are numbers in percentage. All right, so again, numbers given into percentage are going to be talking about exponential, not linear. Numbers to you that don't have any percentages, it's just regular positive or negative numbers, is going to be talking about linear functions. Okay, so again, we're going to read some problems and we're going to have to identify which one is exponential, which one is linear, and just write the equation for it. All right, as part of his biology project, Lewis is observing the growth of two plants. Plant A. Plant A, okay, had an original height, okay? Original means that it starts, okay? So it starts at a height of 5 inches and is growing 1.5 inches per week. So again, when something is growing, that means it's changing, right? Because it doesn't have a set number. It's going to keep growing, means it's going to be changing. All right. All right, plan B. Let's look at plan B, and I'm going to change my color for this one. Plan B, okay? Plan B had an original, again, starts with a height of 3 inches, and its height is increasing by 45% each week. Okay, increasing, don't forget, means it's going up. And we have a percentage number here. So there you go. I know that plan B is going to be exponential. Why? Because of the percentage number. And plan A has to be linear. It's either or, right? All right. Your independent variable, because we have to define the variables and then write the function. Independent, remember, is the one that it's by itself. Doesn't depend on nobody. That's going to be X. And dependent is your Y, your answer, your final answer. Okay? So your independent variable is X. Dependent is your Y. Okay, in the problem, independent variable is going to be X, and it's talking about the height for this plant. So the height is the X. The Y, remember, is the total of something, so the total height. All right, and all we have to do is write the function. Plan A and plan B. I just told you that plan A is linear. Don't forget that linear is Y equals mx plus b. Exponentials are Y equals b, and then remember 1 plus or minus r, and don't forget that r is a percentage number divided by 100. Don't forget that. So plan A, again, is the linear. We already know that. B is the starting point. So I'm going to have Y equals X. And again, you're just filling in the blanks for M and B. That's all we're doing for these, okay? B is the starting point. It starts at a height of 5 inches. And it's growing, I told you, is changing 1.5 inches per week. So there you go. I found my equation for this. Let's do the next one. Again, the next one, you're just filling in the blanks for B, okay? And then don't forget that you have to decide if it's going to be 1 plus or 1 minus. Okay, I already told you that the initial height, I even highlighted, original height means initial height, which is 3. So this is your B. The height is increasing by 45%. Increasing means adding. So it's going to be 1 plus, and R is going to be the 45 divided by 100, which is going to give me 0.45. So it's 1 plus 0.45. Don't forget the little power of x on the side. And so my final answer is going to be 3 parentheses 1.45, because when I add 1 plus 0.45, I get 1.45. And that's my final answer. That's all we're doing. We are not solving anything. We are just writing the equations for these. Okay, let's try another one. As part of his biology project, Sam is observing the growth of 2 plants. Plant A had the original height of 3 inches. Original means the starting point. Plant A, 3 inches. And is growing 2.6 inches. Again, original means starting point. And growing is telling you it's changing. Remember what's changing? Your slope. Your slope is your change. All right, so I know plan A is going to be that, and then let's read plan B. Plan B is an original height of 7, and the height is increasing by 11%. Okay, starts at 7 and it's increasing, which means adding by 11%. Because of this percentage, I know that this has to be exponential. This is the exponential one, because of the percentage. So I'm going to write plan B. I'm going to be increasing by 11. 11 divided by 100 is going to give me 0.11. So I'm going to do y equals, the starting is 7. 1 plus is increasing because of the word increasing, 0.11 to the power of x. And finally, it's going to have 7, 1.11 to the power of x. Let's do plan A. Plan A starts at 3, okay, and it's growing 2.6. 2.6x plus 3. Don't forget that the equations are different. We are using the same variables, m and b, but they are different. This one you write equals mx plus b, and this one I write b first and then the change in here. So that's my final answers, this right here and this right here. That's it.